In this example, I'm going to do part 4 of the Goldfish homework problem from week 3. And just to remind you what's going on here, we've given a goldfish, it's jumping into its bowl, and I haven't drawn out the full picture here. It's jumping from a small bowl to a big bowl. I haven't drawn the full picture here, I've just drawn the abstraction. So it takes off here with some initial velocity that I've drawn down here on a separate x and y axis. It goes up, there's an apex, and then it plops down into the bowl. And what we know is it plops in a distance d away and a height h above, and we know it takes off with velocity v naught. And what makes this problem tricky is that some of these things that are variables are considered to be our knowns, and some of them end up being our goals. And you have to read the problem carefully for context to decide which ones are the knowns and which ones are the goals. So here in number 4, it says use the y component of velocity to find time t1 to rise to the highest point. And that velocity it means is the initial velocity. So it wants us to use this v naught y component of the initial velocity to figure out t1, the time to get to the highest point, the apex. So here that means we're using v naught y as a known, and t1, the time to get to here, is our goal. So I'm going to do some of the analysis here, and this would be a good place to pause and try the analysis on your own. Now, my very first step of this analysis is to recognize what kind of problem this is. And here, this is clearly a projectile motion problem, and the way I can tell is because air resistance is negligible, the object is moving in x and y, and it only is influenced by gravity. So this is a very classic projectile motion problem. It's a little hard to recognize because there's so many variables involved, but if you just think about the physical situation, you can see that that's what it is. And so now I'm going to follow my projectile motion strategies. You know, I've made my drawing, and now I'm going to list my, I'm going to choose my start and end time. I'm going to list my knowns and unknowns. But a lot of my knowns and unknowns will now be variables. So why don't you pause and see if you can do those steps on your own. So the first thing I did in my analysis, if you remember one of the first steps in a 2D motion problem, is I broke my initial velocity into x and y components. And in fact, you should have already done this in question 2 of the homework problem. And make sure that when you do that, show your work to get to this point. All right, and then I also use some of the parts from question 3 in this homework problem in listing my x knowns and my y knowns, right? So because this is a projectile motion problem, I right away know that I have no acceleration in the x direction, my x velocity is constant, and that I have the acceleration of gravity downward, so that's this minus sign here, in the y direction. And this is very similar to that video you watched of the basketball, right? The x velocity isn't changing in time, so the x acceleration is 0, and the y velocity is the acceleration of gravity. And this is the definition of a projectile motion problem. All right, then I put in my initial x and y velocities from here, and notice that they're variables, not numbers, but that's fine because these variables are going to end up showing up in my answer. Then I know my final velocities too. My x velocity hasn't changed because x velocity is constant in projectile motion problems. And I've chosen my end point as the apex. Oh, I forgot to mention that, right? So my start point is when I released it because I know information there. And in this part of the homework, the end point is up here at the apex. This homework, as a progression, as you go into part 6, 7, 8, are there 9 parts? 6, 7, 8. It's gonna end up being a 2-part problem. So here, the thing that's the end for question 4 might end up being the start for a later part. But for here, it's my end point. And so at my end point, I know that briefly at the apex, the y velocity is 0. And in fact, that's why I've picked it to be my end point, because I actually know some information there. Well, and the other reason is my goal to get to that point. So here my goal t1 is in fact the final time, the time at the end. So I just need to find t, that'll be my goal. And now, I also know, because of how I've set my axes, my initial x and y positions are 0, and so now I just needed to use my regular 2D kinematics, and here it looks like I could either use x or y to find the time. I think it mentions using the y component of velocity, so what I'm going to do is kinematics using these as my knowns, time as my unknown, and go from there. So what I need to do is the regular kinematics thing, go look at an equation that has all of these as the knowns and involves time as well, so that we can solve for time. So see if you can pick that equation, and then we'll compare in the next step. Here's the equation I chose as ones that involve all things I know and time my goal. And here I've done my substitution, right? And so often in this step, you will have put numbers in for Vy naught and Ay, but here I'm using the symbols, right? So Vy is 0, Vy naught is V naught sine theta, and Ay is minus G. Now I just need to solve this for t, and I've solved this question. So that's just some algebra. Go ahead and do that on your own. Here's my algebra. I just, I think I'm missing a minus sign. Oh, no, I'm not. I added gt to both sides and flipped the sign. And then I divided both sides by g to get to here. And then this is my final solution. And to do some monitoring, I can carefully read my question. It says your final answer for T1 should only involve the following variables, V naught, G, and theta, and it does. And then I can also use this equation to tell me a story and see if it makes sense. So if I look here, what I'm thinking about is the time to get from the start to the end, to the apex. So this is the time for it to get to velocity 0 up at the top. And if I look at my equation, it says if I throw it with a greater velocity, so say I throw it harder, that if this increases, then T1 also increases. Throwing harder means that it would take longer to get to the top. Now that makes sense. Also, if sine theta increases, then my time would increase. And sine theta increasing basically means that this angle gets steeper and steeper. So the y part becomes bigger and bigger compared to the x part. Or compared to the hypotenuse, really, because sine is opposite over hypotenuse. But anyway, it means steepening up to here, and that makes sense, because if I throw it at the same hardness or same velocity, but I can make it steeper, it should spend longer in the air. So altogether, this equation seems like it makes good sense. Another thing I could do is check the units as another step of my monitoring. And it's also good practice with comparing units, so why don't you try that if you have time to do a little monitoring? I didn't really leave myself much space, so my unit analysis is crunched up in the corner, but I know that the dimensions of t are time, and when I do a dimensional analysis in general, my strategy is to make sure the dimensions on this side of the equal sign are the same as the dimensions on this side of the equal sign. So it better be that the dimensions of this whole blob of variables is a time dimension. And I know the dimensions of each of the things, like V naught is a velocity, so that would be meters per second, or length over time. G is the acceleration of gravity, and it's in meters per second squared, or length per time squared. Sine theta, remember this was a clicker question a while ago, sine theta doesn't have any units because it's a ratio of, say, opposite over hypotenuse, and if those both have velocity, it turns out to be velocity over velocity, which cancels and you have no units. So then I need the units of V naught over G. That's length over time, that's the V naught, divided by G. So you could put it in the denominator, or you can flip it and multiply. That's an algebra trick. So I flipped it upside down, t squared over L. The two L's cancel. The t, one of these t's cancels with this one of these t's, because remember, t squared is really t times t. And that leaves me with just one t, so the units of V naught over G are indeed a time. So here I've finished my monitoring, and this seems to check out completely, and that would be the answer. Now, as you continue, basically it's a very similar strategy for 5, 6, and 7, and you just have to think carefully about what should be your start and end points, and just do your projectile motion kinematics where you list your knowns and unknowns and goals, just the same as you have done in previous questions where there's numbers, but again, in this time, instead of numbers, you end up having variables, right? So for the next step, this time can move up here into a known, and then you can use that to continue.